Welcome back. In today's lesson, we're going to learn the third and last method we use to solve systems of equations. This is called the elimination method. So what is elimination? Okay, elimination is the act of removing something. So that's what we're going to focus on this lesson, is how do we remove something, specifically variables? How do we eliminate variables from our problems? Okay, and we're going to do that by looking at the equations and looking at both equations in the system. It's important to note here that equations can be added together, just like numbers. They can be subtracted. They can be multiplied. And they can be divided. We're going to focus mostly on adding them and multiplying them in today's lesson, okay? So here's what I mean by adding equations together. So let's first take a look at just adding. I'm going to go ahead and, like we did back in elementary school, put a plus sign and put a bar underneath these, like we do like 4 plus 5, right, equals 9. We're adding two things together. That's what we're going to do with these equations. So we're going to combine like terms. -6 plus -2x is -8x. And then what's 2 plus -2? 0. They cancel out. We've eliminated the y's. They're gone, okay? And then we can say equals, in fact, I'll write this a little bit off to the side more, equals 16 plus 24 is 40. Now I've eliminated the y variables, which is really nice. And now I have an equation that I can solve really easily. I can divide both sides by -8 and get that x equals -5. Now, just like in the last two lessons, systems have two answers. So when I get x equals -5, I'm going to take the top equation, but instead of saying -6x, I'm going to say -6, and I'm going to plug in -5 for my x value. Plus 2y equals 16. I'm going to solve this, and I'm going to get positive 30 plus 2y equals 16. I'm going to subtract the 30 on both sides. And I get 2y equals 16 minus 30 is -14. Divide both sides by 2. And I get y equals -7. So I have a final answer of -5, -7. Okay? So that's adding equations together and eliminating a variable. I want to notice really importantly here what's true about the coefficients of the y terms. Notice if I erase this line right here, what are the coefficients here? I've got 2 and -2. So the key thing here is that you want the same value and opposite signs in order to eliminate. Okay? So let's take a look at example number 2. If I want the same value and opposite signs, I'm going to look at each of these equations together. So there's the two equations I'm looking at. 8x minus 8y equals -8, and -x plus 4y equals 25. Neither of these variables will cancel out. If I go and try and add these two together, let's not write this down, but if I go to try and add these together, I'm going to get 8 minus -1 to give me 7x, -8 plus 4 plus 4y, and then I'm going to get 25 minus 8, which is 17. That doesn't help me. That's not good. That doesn't give me any help because I've got two variables still. But if I do decide that I want the same value, opposite signs, I'm going to go ahead and highlight this right here. Notice that I've got an 8x and a -x. I can now multiply an equation by something. I can multiply this whole equation by +8. It's like saying times 8 times 8 times 8 to each thing inside, okay? So what this looks like is I'm going to leave my top equation the same. 8x minus 8y equals -8. But now my bottom equation, When I multiply it, I'm going to get negative 8x plus 32y equals 200. I multiplied every term in that equation by 8. No, excuse me. Now I can go ahead and add these two equations together. I'll put my plus sign here, my line underneath. Notice here now 8 plus negative 8, they're eliminated. They went away, which is awesome. That's what I wanted. So now negative 8 plus 32 is going to give me 24y, and negative 8 plus 200 is going to give me 192. And that's a nice simple equation that I can just divide both sides by 24 and get y equals 8. Now I'm going to have to go back. I'm going to draw a line here. I'm going to take this equation on the top, this guy right here, 8x minus 8y equals negative 8. But instead of y equaling 8, I have 8x minus 8. Instead of y equaling y, I'm going to have y equal 8. Boy, that's a lot of 8s in one equation, isn't it? Now I can go ahead and simplify. 8x minus 64 equals negative 8. I'm going to add 64 to both sides. And I get 8x equals negative 8 plus 64 is 56. Divide both sides by 8. And I get that x equals 7 for a coordinate pair at 7, 8. Okay. For letter B, I'm going to have to multiply and take a look at something else I could multiply by. Notice that A and B are the same exact system of equations, exactly the same. If I erase this highlights, you can see that this equation is the same as this equation, and this equation is the same as this equation. They're identical. But I'm going to show you a second way that you could multiply and get the same answer. What would happen if I decide to multiply this bottom equation now, oops, wrong pen, by negative 2 to everything? The first equation would stay the same, 8x minus 8y equals negative 8. But now I'm going to have negative 2x plus 8y equals 50. And I did that because notice this 8 and 4. How can I turn a 4 into an 8? I want to make sure they're the same value, opposite sign. So if I multiply this 4 right here by 2, that's going to give me a positive 8, and it will cancel out with this negative 8. Just like here, I got a negative 8 that canceled out with the positive 8. So I'm just showing you can do it two different ways. So I'm going to go ahead and now add these together. I get 6x, these cancel out, equals 42. I can divide both sides by 6 now and get x equals 7, which makes sense because I got x equals 7 in the other problem too. Now I go ahead and take my first equation, rewrite it, but instead of 8x, I'm going to do 8 times 7. And hopefully when I simplify this, I get an 8. So 8 times 7 is 56. I'm going to subtract the 56 on both sides. Negative 8y equals negative 64. Divide both sides by negative 8, and I get y equals 8. I'm not going to put a box around that. Instead, I'm going to put a box around the two numbers put together. Notice that I got 8 and 8 in both equations. So it doesn't necessarily matter what you decide to multiply by, as long as, I'm going to go back up to the top here, you have the same value and opposite signs. So you kind of have to think ahead. You got to think a little bit for yourself here, okay? It might not be as easy as just picking one equation to multiply by. Sometimes we have to pick two equations to multiply by. So in example 3, I'm going to notice first the y's because they're opposite sign already. So that's great. I want two things that are opposite sign. But 2 won't cancel with 3, and 3 won't cancel with 2 if I multiply just one equation. So instead what I'm going to do is I'm going to multiply both equations. I'm going to multiply, wrong pen. Multiply the top equation by 3 because 3 times 2 will get me 6. And the bottom equation I'm going to multiply by 2 because 3 times negative 3 times 2 is going to give me negative 6. When I simplify both equations, I'm going to get 12x plus 6y equals negative 12. So I'm multiplying everything by 3. And on the bottom, I'm going to get 12x minus 6y equals negative 60. I multiplied every single thing by 2. Now, when I go ahead and add them together, these 6's eliminate, and I'm left with 24x on the left equals negative 72 on the right. And when I divide both sides by 24, I get x equals negative 3. Now that I know x equals negative 3, I'm going to take this top equation that I'm highlighting in green and rewrite it, but instead of 4x, I'm going to write 4 times negative 3. So 4 parentheses negative 3, and then keep writing the equation. Plus 2y equals negative 4, and I'm going to simplify this for y. I get negative 12 plus 2y equals negative 4. Add the 12 on both sides. I get 2y equals positive 8. Divide both sides by 2, and y equals 4. So now I have a point at negative 3, 4. Okay. So that's multiplying both equations by a number to get one to eliminate. So let's put it all together. Let's take a look at these 3 examples. And we're going to look for same value opposite signs. In letter A, I can see these y's have the same value opposite signs. So I don't need to do anything to these 2, except now just add them together. 2 plus negative 2 cancels out those y's. This is like an invisible 1, so I'll have 4x equals 36. Divide both sides by 4. X equals 9. Then I'm going to take the top equation, x plus 2y equals 9, but instead of x, I'm going to plug a 9 in. So 9 plus 2y equals 9. Subtract the 9 on both sides. 2y equals 9 minus 9 is 0, but don't freak out. 0 is an okay number to have. Divide both sides by 2, and I get y equal to 0 for an answer of 9, 0. Example B, I'm going to look at both equations and ask myself, do I have the same value opposite signs? I don't. 9 is not the same as 18, 5 is not the same as negative 2, but I'm drawn to these 2 numbers right here. And I notice that if I decide to multiply everything in this top equation by negative 2, I'm going to have a negative 18x plus 10y equals negative 22, and on the bottom, I'm going to have that positive 18x. I turned a 9x into a negative 18x, which is going to eliminate my x values. Bring over the minus 2y, bring over the 26, and now go ahead and add them together. These 18s cancel out, which is what I want. I want them to eliminate. And I'm going to, this should be a negative 10y because I multiplied by negative 2. And this should be a negative 22, positive 22 here. There we go. That looks much better. So now I'm going to have negative 12y equals 48. Divide both sides by negative 12. And I get y equals negative 4. I'm going to take that negative 4, plug it back into one of the equations. So now instead of 9x plus 5y, I'm going to have 9x plus 5 times negative 4 equals negative 11. This becomes 9x minus 20 equals negative 11. Add the 20 to both sides. 9x equals 9. Divide both sides by 9, and x equals 1. So I have a coordinate pair at 1, negative 4. So that's multiplying just one equation. You could have multiplied both. You could have gone to this 5 and negative 2 and multiplied both equations by 2 and 5. That could have been an option. But that would have been a little harder for me to think through. So I just multiplied one equation. For letter C, I'm going to have to multiply both equations. I can't turn a 5 into an 8, and I can't turn a 3 into a 7. I can't do that. So instead what I'm going to do is I'm going to multiply this top equation by 7 because I do notice that these are opposite sign. So I'm going to pick the y's to eliminate. So multiply the top by 7, and I'm going to multiply the bottom by 3. On the top, that's going to give me negative 56x minus 21y equals negative 168. Don't worry about big numbers. You might get some big numbers. On the bottom, I'm going to get negative 15x, now plus 21y equals negative 45. Add these two together. The y's are going to cancel out, which is what I want them to eliminate. Negative 56 plus negative 15 is negative 71x, and negative 161 minus 45 is negative 213. When you divide both sides by negative 71, you get x equals negative 3. Now I'm going to go take that, plug it back in. So instead of negative 8 times x, I'm going to have negative 8 times negative 3 minus 3y equals negative 24. And I'm going to solve this for y. This becomes positive 24 minus 3y equals negative 24. Subtract that 24 on both sides. Be careful not to add it. I'm going to get negative 3y equals negative 48. Divide both sides by negative 3. And I get y equals positive 16. So negative 3, comma 16. So I either multiply no equations by something, one equations by something, or both equations by something, okay? Finally, what about no solutions or infinite solutions? So just like in the last two learning targets, we had no solutions, infinite solutions. Let's take a look at what this might be. So I'm first going to hone in on here on these opposite signs. Actually, both of them have opposite signs. So I realize on that bottom equation, I could multiply everything by 3 and the 15s would cancel out. So I'm going to leave the top equation the same. 15x minus 15y equals negative 6. On the bottom, negative 15x plus 15y equals 0. When I cancel these out here and here, let's put the plus sign. Let's draw my line. I get everything canceling out on the left. I'm going to write the number 0 in for the left. I'm not going to leave it blank. And on the right side, I'm going to get negative 6. And then ask yourself, is 0 equal to negative 6? Nope. So this is no solution. For letter B, I'm going to hone in on this top equation, and I'm going to take a look at 7 and 14, or the 10 and the 20, either way. I noticed that if I multiply the top equation by negative 2, that's going to give me a way to cancel out the x's because the x will become positive 14 and negative 14. So on the top, I'm going to get positive 14x plus 20y equals 18. On the bottom stays the same, so negative 14x minus 20y equals negative 18. And when I add these together, this cancels, and this cancels, I get 0 equals 0. Are those the exact same number? Yes, so this is infinite solutions. Okay. So as you do your practice, keep in mind what you want to multiply by, try and predict what would cancel out, and if you need help, you know where to go. Good luck.